Today I will talk about the deviation without dispersion or achromatic prism. Here what we do, we took two types of prism. One is the crown prism. This is a crown prism. It's having a different refractive index. And another is flint prism. It's having a different refractive index. This prism is having angle A and this is having angle A dash. Two prisms are having a different deviations. Angular dispersion of one is different, angular dispersion of another is different. Angular dispersion of one is, that's a delta V minus delta R is mu V minus mu R into A. So angular dispersion as well as deviation of, that's a mean of means a mean of light, that's equal to, this is mu minus 1 into A. This is the mean deviation of a prism. Both depend upon the two factors. One is called refractive index, another is angle of the prism. Both things are depending upon these two factors. Dispersion produced by both the prisms can be made equal, because when we make the dispersion produced by both the prisms equal, then dispersion comes because one is giving the dispersion in one direction and another is giving the dispersion in another direction. When both are having a different direction, when both the prisms are giving equal dispersion, then net dispersion becomes zero. So that's why we are saying and deviation without dispersion. So here in this case, if you look at it, the one, this is a ray that's striking on the surface, and here it will deviate, it will disperse in this way. And the other prism will show the dispersion in this direction, and it has to go in this way, but it will go in this direction. This, after refracting from the another prism, it will go in another direction. It will not go parallel to this earlier incident ray. Its direction will change. So its direction will change. In this case, we have to keep this thing in mind. One prism is showing the dispersion in this direction, another is showing the dispersion in this direction. Both are showing the equal dispersions, but the equal dispersions are in opposite direction. So net dispersion comes to be zero. And so this, there is no resultant dispersion. So this combination is called achromatic prism. This combination we call as a achromatic prism. Here in this case, this is that's a dispersion produced by one prism. And if I talk about second prism, this is, that's V minus delta R mu V minus mu R into A dash, and this is dash. This is the dispersion produced by another prism. So total dispersion, that's delta V minus delta R is the dispersion by 1 plus delta V dash minus delta R dash, dispersion by another. Net dispersion is 0 in both due to both these prisms. So this dispersion plus this dispersion, that becomes 0. I can take for this, that's mu V minus mu R into A plus mu V minus mu R dash into A dash. That becomes equal to 0. So mu V minus mu R into A will be equal to minus mu V dash minus mu R dash into A dash. So A upon A dash minus mu V dash minus mu R dash upon mu V minus mu R. So this A upon A dash is minus mu v dash minus mu r dash upon mu v minus mu r. So negative sign shows both the prisms are in opposite direction. That's why the sign comes to be negative. And in this case, further, if I show this is delta V minus delta R plus that's delta V dash minus delta R dash, that was equal to 0. What I do, I multiply it by delta and divide it by delta. Delta dash or delta dash in this case. This is dispersive power. This becomes mu, that's omega into delta plus omega dash into delta dash. That becomes equal to 0. So this value becomes equal to 0 in this case. And now this condition is for achromatism of two prisms. This is achromatism of two prisms. This is achromatism of two prisms. If I have to clarify that, let us now find out the net deviation. We will find out net deviation. That net deviation is called D. We are saying deviation without dispersion in this case. This net deviation is, one is giving the deviation delta, another is giving the deviation delta dash. So this is called net deviation. And from here, you can, that's omega into delta plus omega dash into delta dash, that was equal to 0. Omega into delta, that becomes minus omega dash into delta dash. And here, omega into delta upon omega dash is equal to delta dash. So delta plus, that's instead of this you can take the sign minus omega into delta upon delta dash, omega dash. So omega dash. So delta we took outside, 1 minus omega upon omega dash is the value of net deviation. So this is the net deviation, that's equal to deviation into 1 minus omega upon omega dash. Here in this case, as two prisms are of different materials, one is having a different, so omega will not be equal to omega dash because both the prisms are of different material. So in this way, hence there exists some deviation. So this, although there is no dispersion because omega and omega dash are not equal, so there exists some deviation, although dispersion will not be there, but deviation must be there. So this is all about the deviation without dispersion. Thanks, have a nice day.